to the Science Channel. I'm your host Ayush, and today's topic will be frequency and pitch with our guests as Ryan Chu and John Miller. Today, our first guest will be John Miller. Hi John.
Hey Ayush.
Are you prepared to answer our science questions?
I am.
Okay, our first question is, what is Hertz?
Hertz is one complete wavelength per second. It is a unit for measuring frequency and pitch.
Can you please explain us what pitch is?
Pitch is the quality of highness or lowness of a sound.
What's ultrasound?
Ultrasound are sound waves in the range above 20,000 Hertz, and infrasound are sound waves with wavelengths below 20,000.
John, would you happen to know what resonance is?
I would. Resonance is when the amplitude of a vibrating object adds together with the amplitude of the second wave. The strengthening of a second wave in this way is resonance.
Interesting. Do you know what frequency is?
Frequency is the number of wavelengths passing a fixed point in a certain amount of time.
John, would you happen to know what a medium is?
A medium is any substance that a wave moves through.
I heard you were talking about an amplitude before. Can you explain?
Amplitude is the distance between a line to the middle of a wave and a crest or a trough.
What would happen to be a crest?
A crest is the highest point of a wave, and a trough is the lowest point of a wave.
How interesting. John, this brings us to our last word. Would you please define what a constructive interference is?
Constructive interference is the interference of two or more waves of equal frequency and phase, which produces a single amplitude equal to the sum of the amplitudes of the individual waves.
A job well done, John.
Thank you.
Welcome to the second part of our show. Our new guest today is Ryan Chu. Hi Ryan, welcome to our show.
Thanks.
Are you prepared to answer our science questions?
Yes, I am.
Our first question is, what is the Doppler effect?
The Doppler effect is the change in pitch when the sound comes toward you or away from you. The pitch gets higher when it comes toward you and lower when it goes away from you.
An example of the Doppler effect is a police car passing you. As it comes closer, the sound waves are spaced closer together. Therefore, the frequency and pitch are higher when it reaches you. When the police car has passed you and gets farther from you, the sound waves still move towards you, but the waves are farther apart. The frequency decreases, therefore you hear a lower pitch.
Exactly.
Ryan, would you happen to know why the Doppler effect was not noticed until the 1800s?
Well, the Doppler effect is noticed on the things that have higher frequencies and are faster. Technology before the 1800s was not as advanced as now. Therefore, transportation cannot move as fast, making the Doppler effect almost unnoticeable.
Thanks, Ryan. Ryan, I heard NASA was doing a research on how if galaxies are coming closer to us or if they're getting farther away from us. Can you please explain how this is related to the Doppler effect?
Yeah, scientists are looking at the frequency and pitch of the light and sound waves reaching us from other galaxies, letting us know if the galaxy is getting closer to us or getting farther away from us.
Thanks, Ryan. We are now going to get back to our old guest, John Miller. Welcome back, John.
Hey Ayush.
Are you ready to answer our questions?
I am.
Okay. Earlier in the show, you were talking about frequency. Can you please explain how this relates to humans to other living beings?
Well, humans can hear 20 to 20,000 Hertz. Mosquitoes can hear 200 to 400 Hertz. A tree frog can hear 50 to 4,000 Hertz. And dogs can hear 40 to 50,000 Hertz. People use high-frequency sound devices like dog whistles to keep pests away. While humans cannot hear the whistle or sound device, certain animals like dogs or bats can, and it is a piercing sound for them. They try and get away from this sound.
So John, I've been hearing you talking about pitch, frequency, and wavelength. How are these three related?
When pitch and frequency increase, the wavelength decreases, and when pitch and frequency decrease, the wavelength increases.
Thanks for your help, John. Now goodbye.
Okay, thanks.
Yeah. Now we're going to be welcoming our guest back, Ryan Chu. Hi, Ryan.
Hi.
Welcome back to our show.
Thanks.
Are you prepared to answer our questions
Yes,
today?
I am.
We have been wondering how a hearing aid works.
Okay, a hearing aid uses amplification to make it easier to hear. The word amplification comes from the word amplitude. Amplitude is the measure of the height of the wave's crest. By increasing this, the sound gets louder, making it easier for people to hear.
So Ryan, if you could actually see waves of low-pitched and high-pitched voices, which would have a greater number of compressions in 1 second?
Well, the high-pitched voices would have the greater compressions because it has higher frequency, therefore having lower wavelengths.
Good job, Ryan. And this leads us to our next question. So what do voice identification security systems have to do with frequency and pitch?
Voice identification systems use voice prints to work. Voice prints recognize wave patterns produced by a certain person's voice and then only respond to that person.
Good answer, Ryan. Can you please explain why some singers have really nice voices and some have really bad voices?
Well, each person's voice is unique because of the shape of your vocal cavities and how you move your mouth when you talk.
Right, Ryan. So, Ryan, what makes high notes and low notes on musical instruments sound so different?
Well, when you place your fingers on the fingerboard, the vibrations of the string is different, which makes the pitch different.
I see. And that wraps up our show today. Thanks, Ryan.
Thanks for having me.
See ya.
Bye.
Bye.